I've got this bench put together for the table saw, and it's going to replace the one I've been using, which is mobile, and become sort of a permanent table saw base. This sliding table saw component that I'm starting to put together, this is one of two pieces that make up that whole slide. So this slide moves half of the distance, and the other one will sit on top of it and move the other half. And so that collectively they'll move big enough that I can use large panels and sort of replace a miter gauge or a little miter track or a sled. That part is a lot of engineering and a lot of little small fine details, and so I'm going to focus on that in this episode. And I was short one little part that I've got ordered now. It's a chain, and I'll use those chains and some sprockets to try to engage those two different things and coordinate their movement. So I have to do a little bit of machining, a little bit of welding. I'll do some woodwork and put all this together, try to be really precise about it and get that thing to be really linear and really able to adjust so that it goes just completely parallel to the saw blade in the end. That's the goal here. So we'll see how it goes. Welcome back to Outbuilding. This is a channel where I build things, and I've got different playlists for different kinds of builds. So this build is for the workshop, which I'm in here, and I'm switching from a mobile area down below here in the workshop to an upper level that's going to have a big, large fixed workstation island. And that island is going to be built out of different modules, one of which will be this table saw module. And there'll be drawers and other things built in there. And the whole goal is to have everything kind of right at hand, have a really flat surface to work on, and be able to do larger things like cabinets and other stuff with really good accuracy, benefiting from that permanent workstation. So let's get started on the next steps of this thing. It'll be fun to see how it goes together, and I hope it works well. So far, it's with some care, it's really kind of coming out nicely. So I look forward to seeing the next step. I'm gonna jump around a little bit here because today is the day before a holiday and a holiday weekend, and I wanna make sure I have all the parts in hand so that I can work over the weekend. So I may need to run out and get some hardware, and I'm gonna take a look at this first to start, and you'll see how this all comes together once I put these pieces together. So it seems like whenever I try to build something mechanical, I look first at the little part catalogs, and stuff's super expensive for like a sprocket or a gear, and I did the same here. I was looking at timing belts at first to coordinate these two. That would work, but they're pretty expensive. And then I looked into go-karts, and it turns out go-karts all use this sort of ANSI 35 chain, which is really commonly available because of that. And then there's a bunch of pretty inexpensive little sprockets and axles and things. So I'm going to try to use this chain, which we would normally run in a loop. In my case, I just want to run it end to end and have this thing kind of walk back and forth on it, almost like a rack and pinion. I'm going to use a link of chain. I'm going to try to pop the link open, weld it onto a bolt head, and see if I can't use that bolt as a tensioner to kind of affect what I want to do. For breaking the chain, I'm using this really inexpensive, I think it was $19. It's a little chain breaker that's meant for a bunch of different chain sizes. So it's kind of imprecise, but it basically just acts as sort of a vise that drives a pin through with a lead screw to shove one of the pins out of the chain. And it got most of the way out, and then I had to stick the remainder in a vise and sort of punch out the pin the rest of the way. And then with one of the smaller internal links secured, I dug around in my bolt bucket and looked for a bolt that not only was a common size, so I'd have backing nuts for it available here in my shop, but also that didn't have any zinc coating so I could weld on it. And then to give myself half a chance of being able to weld this on coherently, I cut a couple of grooves in the top of the bolt head with the cutting wheel. And just that helped clean off some of the material so that I had a good raw metal to weld against, but also gave me kind of a couple grooves to seat that thing in so that it was going to stay in position while I tried to tack weld it. The results of the first link and bolt looked pretty good, so I went ahead and cranked through and got all four of them done. So I had an end for each side of the chain for two chains, one for each of the slides. My bolts all set up, I had to switch the shop around so that I could get out the welding table and try to tack up these bolts and see how they'd work. For me, small parts like this are only as easy to weld as they are clean, so I straightened them all up, got them all set up, and wiped them down with acetone just to get any oils off and try to improve my weld quality. So with everything tidy, I went ahead and used the TIG to try to weld them up, and the flats on the links are really thin, so it was challenging because I didn't want to burn through them, but I was able to tack them up. Okay, so here's my thinking on this. These links I was able to weld onto these bare steel bolts, and then each of the chains comes with some master links, so I'm going to hopefully use the master link here to put that together with the bolt, and then I can then I can have the chain fixed to things, and the bolt's a little bit adjustable, so I can put some tension on the chain or not. There it goes. That should work pretty well. And I was kind of careful to keep a flat on there so I have a place that I can still stop the bolt from spinning when I'm tightening or loosening it without twisting the chain. So I think that'll work pretty well. All right, so the next thing in this little experiment is I've got these bearings, and they're gonna sit inside of a little plate that I'm gonna make, and that plate's gonna get mounted on either side of the sliding box that I've got, and then axles will run through those. First, I'll cut this scrap down to size, and then I'll get on the CNC mill and I'll mill out the little path for that. It always takes me a little while to write that code and get that set up. So I'll show you those steps, but I'm gonna cut out these plates first, so I've got kind of my blank to work with. The CNC coding is kind of involved, and I'm going to just give you a really quick overview, just kind of the steps I go through. But if you are curious about it and want to leave a comment below, I can do a whole video on that, just that goes through it, like, piece by piece, and shows you how I'm doing the coding. I do it a weird way. I write the code by hand. It's just kind of what I'm used to doing. There's a lot of tools that do it as well. So I'll show you real quick. All right, I start with a model of the entire piece that I'm going to do. And in this case, I'm doing this little plate. And so with that model, then I can switch over and do a drawing. And you can see here, I've got the plate laid down, I've got everything else removed, and then all my dimensions show both millimeters and inches. And I've found it really useful in this project to switch between millimeters and inches just for various things. I'm a machinist, and so I see things in decimals, and so the metric actually makes some sense for me. But then I'm doing a bunch of double checking I'll put it down in millimeters and then check it imperial or vice versa. So here you can see the plate isolated. I've got everything else and it's in 2D, and I've just dropped down dimensions. And the dimensions are the critical ones that I need when I'm writing my code to know where to start and stop these radii and put down the holes and everything. So then I switch over to a text editor and I work there. So you can see here that the code is sort of its own dark art. I won't go into this in full detail, but you can just see it's code that is got all the increments and measurements as you see on the left here in the 2D drawing. I translate that over into the code and do sort of basically straights and turns. It's pretty simple when you actually break it down. I put a lot of comments in there so I can look back at it, and I forget this stuff every time I do it. So I go back and I pull up some old file I've done. Hopefully I put good comments in there and I can change the dimensions and kind of clean it up and kind of run a new toolpath. So I sit on the computer and get as far as I can with the coding, but then I move down here, and actually the control software has a pretty good viewer of the toolpath. I also cut one extra panel because it seems like every time I do this, I might goof up the first piece or have something not go quite right. It's easy enough to run 3 pieces through, even though I need 2 in the end. I've got the code here, so I'll switch over and show you how I set this up. This is what I would call 2D milling, because I'm really just doing a path around the outside and putting in some holes and some countersinks and things, but I'm not really doing 3D profiling or anything. When I first turn it on, the mill doesn't understand what position it's in, so I do what's called referencing, where it runs to the X, Y, and Z axes extremes and hits the limit switch, and then it can know what its position's in, and everything it does is relative to that from then on. Then I use the jog wheel to put the bed kind of in the middle of its positions. So I'm going to have 3 different passes with the milling machine, and the first pass is just going to cut 4 accurate holes that happen to be the final mounting holes for these plates. Then I'll use those holes to mount that plate down onto a fixture and then run profiles and cut the rest of it out. To start with, though, I just need to put down the milling vise so that I can hold those plates and get those 4 accurate holes cut in each of the plates.
Because I'm going to be milling in the very middle of these plates, I don't have to be really super accurate when I put these in the vise. I just need to get them in there held really well so that I can get 4 accurate holes mounted. The holes will kind of create the accuracy from here out. So for each of these holes, I have 3 operations. I'm going to use a center drill to create an accurate start to the hole. Then I'm going to use a drill bit to go all the way through the hole. And then finally, I'll come back with a countersink to accommodate the screw head that's going to be sitting there so that it's flush. And each of these is very carefully measured and recorded in the mill so that the mill has an offset and understands, what its height for each of these different tools is in a given pass. And so since I'm putting a new drill bit in, I'm going to put that drill bit into my little measuring stand on a piece of glass, and I'm going to use that to kind of record in the software for the mill how tall that drill bit is as I put the drill bit in so that it knows exactly where it's going to start drilling. So we've added dimensions with the milling vise, and we put a piece of material in there, and the mill doesn't understand quite yet how tall that is. And so here I'm putting in a dial indicator that's measured. I'll drop it down and zero it out, and then I can zero the mill so that the mill understands exactly where the top of that aluminum is, and it can use those offsets for the tools to know when it's going to start penetrating the material. So when I'm cutting aluminum, I use flood cooling, which is sort of a water-soluble coolant, and it makes a mess. So there's this little shell that kind of contains everything in there, and it dribbles back down and recycles. And then I'm doing what is literally a dry run here of just kind of running through the code to see if it does something that makes sort of sense and looks like what I would expect it to do, with no drilling bit in there and no cutting fluid. With the dry run checking out, I go ahead and load up the center drill and start the passes with the code. Then after each tool is finished, the machine prompts me to switch out the tool. I grab it and take the old one out, put the new one in, and then say go again, and it continues back on the code path with the new tool. Once the holes are all drilled, I switch to the countersink and drop those countersinks in, and that completes the hole pattern for each of these plates. So when that pass is done, I pull the plate out, take a look at it. It looked pretty good. And the only thing I noticed was that the screw was a little bit proud. So I adjusted the code. Remember, this is one of 3 plates. So for the subsequent 2, I dropped the countersink down just a little bit deeper so that that would sit more flush. And then I run through the rest of the plates.
So that seemed like a really long way to and complicated way to drill what amounted to 12 holes, but they're really accurate. Got these plates with countersunk holes that they look messy because there's other stuff that's all going to get cut away. And the way I'm going to do that is I'm going to use those same holes on a big piece of aluminum as a fixture plate. So I'll cut 4 holes that correspond in the fixture plate and thread those, and then I can screw the plate down, and then I can run around and mill the edges of the plate and cut the plate away in the places so that I've got the plate I want.
With the vise work finished, I can take it off and put the fixture plate on, and then I just go ahead and run a different pattern that uses the center drill again, a different size drill bit that accommodates the tap. Then I come back and chase all the threads with the tap so that I've got a spot to work with. And it doesn't really matter where I put this on the plate as long as I'm free of the other holes that are in the plate, because I'm going to cut into this plate a little bit when I do the profiling as well. With the fixture plate all drilled out and the holes tapped, I can then just clean it up and mount the plate down. And the key here is that those holes were cut really accurately with the mill, and I haven't moved anything, and I'm putting the plate down, and so the plate holes are registered exactly where the mill holes were, and that's how I'm able to get everything really accurately machined. I'm going to use a little cheat here where I'm putting down a piece of 3/8 inch steel, and then I'll zero out the Z-axis on top of that. So actually I'm going to cut 3/8 inches above where I want to on my first pass, just to kind of watch the code and make sure it's doing everything and it's going to clear those fixture bolts and everything. I already broke a bit on my first drill pass because I had the mistake in the code, so I'm being a little careful here, but this is a good step to do. So I'm kind of air milling, if you will, and then I can go back and drop that down and re-zero it once I know everything looks good. It's always a little bit nerve-wracking, but at some point you need to commit, and so this is sped up quite a bit. It takes about 10 minutes to do this whole pass, but I'm doing sort of passes about 5/500ths of an inch each pass, and carving my way down on the outside of the path. And then when I'm done with that, I'll go in the center and I'll bore out the holes for the bearings, and they're pretty accurate. They're within 1,000th or 2 of what I need, and so it's easy to dress these parts up when I'm finished. With the part cleaned up, I test fit the bearing, and it was a tight fit, but I can kind of clean that up and also press it in. It looks really good. So then I just had to clean up the mill and run the other parts. Okay, that was a bit of a fight. Actually, that was a big fight. I just needed these 2 plates. They worked out great. I'm really pleased with them, and I can move on and start doing the stuff I want to do. I had all kinds of problems with this. The coolant had turned to sort of like cheese, because it does that every few years. It seems to go off and it smells really bad. So I had to clear that out and clean it. The GFCI kept tripping when I'd start the mill, so I had to disengage the GFCI. I'll figure out what's going on with that. I crashed the mill and broke a bit. I broke the tap off when I put the plate down. I didn't show you that, but I had to redo the plate. That worked out okay. Just a whole lot of things that were just a mess. And so every once in a while, it's just a fight to get something done. But I got these done, and I can move on to the next phase, and I'm looking forward to it. Thank goodness I'm done with the mill for now. So I got my plans here for the wooden portion of the secondary slide piece. It's 13 different pieces. Some of them are redundant, some of them have similar routes, and so I'm going to exploit those redundancies, and you'll see how I put these together, but I'm going to start by breaking down a couple of sheets of birch into the pieces I need. This Baltic birch plywood is 18 millimeters thick, and I've got an 18 millimeter router bit here, and I'm going to use that to create a bunch of grooves in the boards, but I don't really know what the offset is from my router base. So I just put down some scrap wood, did a quick little test cut, and then I could measure to see what that is from a straight edge and mark that down so I know kind of what my offset is. And then I can use that math to just figure out how far off to put my straight edge when I'm doing these grooves I need to put in the boards. I'm setting up to cut these grooves, and not all of them go all the way from end to end on the board. And then when this is all done, I'll cut this board down into 4 different pieces.
All right, so it's time for a break. I made my fourth and final flaw on this board, and I'm going to start over and redo this board, and I'll explain what they are. The first one I did was when I cut the overall first dimension, the sled wasn't set up quite right, or the track rather, and so it's just a little bit off, not very much, and I could have lived with that one, that was fine. Second one that happened is when I was running this router, I didn't clamp down the far end enough and it moved on me a little bit, so I ended up opening up my groove, which again, I could probably survive that one just if that was the only problem. And then the one that I did that is just such a common problem, and you always kick yourself when you do it, I measured to the wrong side of the router, and so the router groove. So I've got a dado, it's right where I want it to be, and it's exactly 18 millimeters, which is the width of the board off of where it should be. I just did the math funny in my head. And then the last thing was I just checked the depth of this groove, and it's a little bit too low. Collectively, that's just enough to kind of redo this board. I want to make sure this is really good for the saw. If this was a cabinet or something, I could easily just kind of work around this, but not for this one. I can reuse this wood for some of the other stuff I'm doing, so I'm not gonna, it's not probably the exact form factor I wanted, but it's not gonna go to waste, which is good. Anyway, I'll take a break, have lunch, come back and cut this board and get caught up to this same spot again, and then we'll pick up from there. That's the way it goes.
So one big win on the second pass was I switched from the level, which was hard to kind of clamp down, to the track saw track, which is way easier and it's made for doing this. And so it's a great straight edge. I cut some little gauge blocks based on that measurement I made earlier because I want to route around the edges, and I need to do the whole perimeter of this board and some other boards. So these gauge blocks will come in handy, and it's just a really easy way to line things up by feel and get it super accurate without having to measure anything.
Second time's a charm. That worked really well. I was able to get the edges all done. This board, since this is kind of a series of parts that are going to create a box that has fins going across it, I want those fins to line up. So by running the grooves here, I'm going to cut this down into the four pieces that this makes up. And each of those grooves will be completely aligned, even if they're slightly off from what they should be. They're actually pretty close, but if they're slightly off, they're all going to line up really well, so that'll make a really good square and tight box. These grooves are only 1/8 of an inch deep, and they don't need to be very much to kind of lock the box up and give it a whole lot of structural rigidity. So I'm going to go ahead and break this into the four pieces, and then I can work on, I got 9 to go after that.
Doing these all in one board is a benefit in the sense that they're really accurate, but I also realize the drawback of if you make a mistake, you ruin 4 boards at once. But now I'm cutting this one board down into 4, everything matches, and this is pretty easy work on the table saw.
All right, so I got 4 of these cut out, and now I need to cut 6 that are actually identical, and they're kind of funny looking shapes. They look a little bit like a hard carpenter square, kind of a right angle piece. But I've got a way, I think I can cut them back to back out of panels and then kind of improve them, and I'll use a router to clean them up and get them all to be the same dimensions.
For purely random reasons, these ended up just being square panels when situated back to back. So the first thing I did was knock out 3 panels that are exactly the same. And then I'm measuring out, I'm going to use the table saw to cut partway through, but not all the way through. And I'll show you how I do a stop block in this first pass. So there's not a very good view, but the second pass, there's a much better view of it. With those first parts done, I just use the jigsaw to freehand cut these things into 2 pieces. Here you can better see that stop block. I raise the saw blade way up and I look at right where the very first part of it's going to hit the wood and measure that off. And then I put a stop so that I get just to my mark, so I don't cut any further than I need to. And I clamp a stop block onto the fence and I'll flip around the other side. Here you can better see it. And I had to transfer this one over because the clamp was going to get in the way, but I got it all set up and then I could run and have it stop. And the only trick is you stop the saw once you get to that spot so you're not backing the wood out with the moving saw. It's then pretty quick work to use a handsaw to just clean up the last little notch in this cut and then file it out and trim them up and get them all matching. I then need to repeat the saw stop block approach to cut a notch in the tails of these things, and it's on the inside, so it's a little bit harder to get to. The same process. To finish up this little notch was a little bit tricky because I couldn't reach it with the table saw, and I decided to use, at first I thought I'd use the track saw, but the track saw didn't fit in that space. So I clamped all these together and then used the router to kind of clear out the other half of this notch and get them all smooth and level. All right, well, those worked out pretty well. Those are the six, they sort of act as sort of like ribs, like almost like an airplane wing. I gouged a little bit here with the router right when I was finishing up, but that's just for a support brace, so it's gonna work just fine. So I got 10 pieces now, and I've got 3 really simple ones to do, and I'm just gonna cut those out real quick on the table saw. Then I can start putting the stuff together, or at least dry fitting it, see if it all is starting to fit, and then kind of do the customizations to each piece before I assemble it. All right, so let's try to make sense of these pieces. Well, for a first fit up, I'm pretty pleased with that. There's a couple little things I can sand and refine, but it actually is going to lock up really well, and I think it's going to be pretty sturdy with all those ribs in there. So there's some things I need to do to create spots for the linear rails. There's going to be 1 here and 2 sitting up here, and I need to kind of prepare for those. And so I'll pull this back apart and drill out these and also give myself access so that when I'm putting the bench top on it, in the end, I've got ways to capture those pocket screws that are going to hold down the bench top. But this is a good start, and I think the 1 or 2 little mistakes I had, I was able to recover from. To glue this up, I decided to do it in sections so that I could focus on each joint and make sure that I got everything clamped really well so that it ended up really square and flat. So this is the first pass where I'm just gluing together the ribs onto the what is actually the floor. And then I'll flip over and start working on the black box and getting it put together. So if you watch part 1 of this saw build, I put these rails in just to kind of test things out. I'm going to pull these are the little blocks, and these are going to get mounted over on the saw. And I'll pull them out. And then I'm going to pull these rails out because there was a little spot in here that I cut part way away so that I could glue the box up, and now I need to cut the rest of it off. There's some holes we built. Our plates are going to go here, and the axles are going to go through, but I get these rails up out of the way, cut that out,
finish that stuff up. Then I'll install in all the rails and get everything kind of tucked in so that this thing can kind of get permanently mounted down on the bench there. I want to make sure that this is all done so that when I go to organize and set up the next one, I can do it relative to this thing where it ever lands.
I'm just going to use an oscillating tool to cut out that interior bridge piece. Then I was able to mount the plates, and the bearings were just a slight friction fit, so I sanded just a little bit and got them so that I could press them in, and then they just screw into the sides of the box and provide a good stable surface for the bearings. So I repeat this same process on the other side, and then I test fit the axle, which is a really tight fit, but it does go in there well, and it's going to work just great. I'll cut it down when I finally do it, but I just test it to make sure that it's going through and it actually spins. And then another thing I need to do quickly is to put some screws in to hold the back on. The back needs to be able to be removed so that I can load this box onto the saw when the rails are in place, and then I screw it back on when I'm done.
Yesterday at the end of the day, I went ahead and glued up the second wave of this piece that's all going together, and now I can put those two sub-assemblies together and hopefully get it nice and tight. And then while that's drying, I'll jump over and I'll route and finish up the black box that is the first stage of the slide, and start mounting it into the workbench.
With the box done, I can start mounting the rails, which have a really sharp corner on them, and it makes the bearing blocks hard to slip on, and I got to do 3 at the same time. So I'm just going to relax and chamfer the edge just a little bit so that the bearing blocks load up a little bit easier. I have a close interference with these lower bolts, and so I'm putting these blocks on the top first, and then I'll load the rail in after so that I can reach the bolt heads. A little test fit with the rail to see how the chamfer works, and it works great.
I've run into a little bit of a snag, and I think I can fix it. I had checked the clearance of the rail with the bolt heads or the Allen heads on these blocks, and I was more concerned with it interfering with the rack down there, but didn't realize that these little cars that run on these rails are running into it, and it's not very much. So I need to take a break and figure out how to resolve that. I'm kind of glad I found it now. It's super easy to fix, but I can't really move forward until I get it done because I don't really want to screw anything down until I have these put in place as reference for where I'm going to put the holes in the shop. So I'll stop here for now, figure that out, get back to it once I've got a solution. Well, I didn't quite make it to where I'd hoped to make it to in this video. I was hoping to get this all hooked up and have the sprockets engaged and doing it. Didn't quite get there. I've got a couple clearance issues, and I've just run out of time for this video. It's gotten quite long, But I can ponder that clearance issue that I came up with. That's going to be an easy one to avoid. And then I just need to continue putting this together. I'll hopefully get back to this thing fairly quickly. I've got to run out to the coast and do a project out there, which will be kind of fun. I'm building a big canopy over a water tank. It's out of wood too, but then I'll be back here and get these things resolved and move on, and I'll get part 3 up for you shortly. Really fun project. I really appreciate you watching. It's fun to have you out here, and this was a really popular series so far. So I apologize for not having it just wrapped up and show you the kind of fun thing at the end of this, but it's coming together really well, and I look forward to the next episode. I hope to see you there. Until I see you next, I'll be out building. Thanks again for watching.